Joe, thanks for stealing my thunder, man. Obviously, you've seen that video, but the point is still the same. That when you take air out of the equation, okay, it doesn't matter what the mass is. It's going to fall at the same rate due to the acceleration of gravity. All right, and back to the dropping rocks from bridges. Okay, this time I've got an acceleration, I've got an initial velocity, I've got a time. Okay, what's the distance that it falls? Let's go back to this equation, right? Throw the numbers in there. It's a little over 7 meters. And you guys all got to go do experiment 9.3. And then you use this equation. And hopefully you discovered that it works pretty good.
Yeah, except that I had to have my son show me how to do math. He's 12.
Hey, 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 we're back to 1 Corinthians 12. It takes all types to get the job done. God created us to be in community. Let's go for it. All righty. So there's other ways to measure height. And here's an example. And this concerns a question on a physics exam at the University of Copenhagen. And the question was, describe how to determine the height of a skyscraper with a barometer. And one student replied, you tie a piece of string to the neck of the barometer, then lower the barometer from the roof of the skyscraper to the ground. The length of the string plus the length of the barometer will equal the height of the building. Well, this original answer so incensed the examiner that the student was failed. The student appealed on the grounds that his answer was indisputably correct, as the university appointed an independent arbiter to decide the case. The arbiter judged that the answer was indeed correct, but it was decided to call the student in and allow him 6 minutes in which to provide a verbal answer which showed at least a minimal familiarity with the basic principles of physics. So the student comes in, and for 5 minutes he sits there in silence. At which point the arbiter reminded him, your time is running out. To which the student replied that he had several extremely relevant answers, but couldn't make up his mind which to use. So he said this. Well, firstly, you could take the barometer up to the roof of the skyscraper, drop it over the edge, and measure the time it takes to reach the ground. The height of the building can then be worked out from the formula h equals 1/2 gt squared. Does that look familiar? But he said bad luck on the thermometer. He said, or if the sun is shining, you can measure the height of the barometer, then set it on the end and measure the length of a shadow. Then you can measure the length of the skyscraper shadow, and thereafter it's a simple matter of proportional arithmetic. Figure out the height of the skyscraper. He says, but if you wanted to be highly scientific about it, you could tie a short piece of string to the barometer, swing it like a pendulum, first at ground level, then at the roof of the skyscraper. The height is worked out by the difference in the gravitational restoring force using this equation. He said, or if the skyscraper has an outside emergency staircase, it would be easier to walk up it and mark off the height of the skyscraper and barometer lengths than add them up. And he said, if you merely wanted to be boring and orthodox about it, of course, you could use the barometer to measure the air pressure on the roof and on the ground and convert the difference in millibars to feet and give the height of the building. But since we're constantly being exhorted to use exercise, independence of mind, and apply scientific methods, undoubtedly the best way would be to knock on the janitor's door and say to him, if you would like a nice new barometer, would you give me I'll give you this one if you tell me the height of the skyscraper. This guy was Niels Bohr, the only guy from Denmark to win the Nobel Prize in physics. Thinking he knew a little bit about physics.